By 2026, autonomous AI agents won't just be assisting. They will actively influence 40% of all enterprise workflows.
Which is just a massive shift.
Right. That is a direct projection from the McKinsey Global Institute. And, if you're a European business leader or a CTO or a developer evaluating your tech stack right now.
Yeah, you need to be paying attention.
Exactly. That is not some science fiction scenario for the distant future. That is literally your roadmap for the next quarter. So, okay, let's unpack this.
Let's do it. Yeah.
Because going from a world where a chatbot helps you draft a polite email to a world where autonomous systems are actively steering nearly half of everything your company does, I mean, that is a staggering operational leap.
It really is. It requires a complete rewiring of how we think about enterprise architecture.
Right.
And the timing we're seeing in the research, it isn't just about the technology reaching a maturity tipping point. We are looking at a direct collision between hyper-accelerated AI capabilities and strict new regulatory frameworks.
The regulations are huge here.
Absolutely. Specifically, the mid-2026 implementation deadline for the EU AI Act. That is forcing a massive structural shift in how these systems are deployed.
Yeah, the compliance clock is ticking loudly for anyone operating in the European market.
It is. And that tension between innovation and regulation is really the mission of our deep dive today.
Right, because we're looking at a stack of recent research and case studies, mostly centered around Tampere.
Yeah, Finland's second largest city. It's this rapidly growing industrial technology hub.
And Tampere sits perfectly at this intersection, right? Heavy industry and European governance.
Exactly. So we're going to explore how organizations are deploying complex multi-agent AI systems while staying unequivocally compliant with the EU AI Act.
Which is no small feat.
Not at all. We're looking at how companies are taking what appears to be a terrifying regulatory hurdle and engineering it into a competitive moat.
I love that framing. But to understand why those 2026 regulations matter so much, we first have to establish what these new systems are actually doing. Because we are no longer talking about a single AI interface that you just type a prompt into, we need to look under the hood at the transition from single-agent AI to multi-agent orchestration.
Yeah, and the limitation of single-agent AI is fundamentally about processing architecture.
How so?
Well, early AI models, even the highly advanced ones from just a year or two ago, they process information sequentially.
Step by step.
Exactly. They receive a prompt, compute a probability distribution, generate an output, and then they just sit idle waiting for the next human input.
Right.
So in a complex enterprise environment, if you give a single agent a multi-layered problem, like, say, rerouting a supply chain due to a weather event, it creates an immediate computational bottleneck.
Because it's trying to do everything at once.
Yeah. It tries to solve the logistics, the financial impact, the vendor communication, all in one massive sequential thought process. It struggles with context collapse and just quickly breaks down.
So a single agent is essentially like an incredibly brilliant intern.
Oh, that's a good way to put it.
Right. Like, they are fantastic at one highly specific, bounded task. If you hand them a messy spreadsheet, they will optimize it perfectly.
Right.
But if you ask that one brilliant intern to suddenly run the entire company, manage the supply chains, handle the customer service queue, perform risk assessment on the fly, they're going to completely melt down.
They absolutely would.
Multi-agent orchestration, on the other hand, sounds a lot more like hiring an entire synchronized executive suite.
That is the exact architectural shift. Instead of one overwhelmed intern, you deploy a network of specialized autonomous systems, and they communicate with each other asynchronously.
Okay, so they're independent but connected.
Exactly. You might have one agent strictly trained to monitor sensor telemetry on a factory floor,
Right.
and another agent is exclusively monitoring spot prices for raw materials. A third handles vendor contract negotiations.
Wow.
And they don't need a centralized human controller to tell them to talk to each other. They share data and trigger workflows autonomously based on predefined operational parameters.
That seems like it would create a massive speed advantage. But I am curious what that actually looks like in practice. The source material references a 2025 AI operations study from Boston Consulting Group, right?
Yes, and the BCG data is definitive on this. Organizations implementing multi-agent orchestration are reporting 45% faster decision-making cycles compared to legacy automation systems.
That's incredible.
And alongside that, they are seeing a 30% drop in core operational costs.
Wait, hold on. A 45% reduction in decision time.
Yep.
That implies the bottleneck in legacy systems wasn't the data gathering. The bottleneck was the human approval layers and the time it takes for different software silos to sync up.
Precisely. It really comes down to parallel processing. In a traditional system, step B cannot happen until step A is finished and validated.
Right, the sequential issue again.
Exactly. But in a multi-agent network, the agent dealing with logistics is already adjusting shipping routes the exact millisecond the procurement agent detects a delay from a supplier.
Wow.
They're passing context windows to each other in real time.
Okay, but if these agents are operating as an executive suite and making those lightning-fast logistical decisions, they can't just operate in the dark reading text logs.
Right.
Which means we have to talk about how these systems actually perceive the world around them. Multimodal AI.
Yes. Giving an AI system a rich, contextual understanding of its environment is what unlocks true autonomy.
Because before, they were kind of blind.
Completely. Traditional agents lived entirely in a text-based reality. They parsed code, read emails, analyzed structured database queries.
Okay.
But they were getting a highly filtered, translated version of reality. Multimodal agents process text, images, video feeds, and audio streams natively and simultaneously.
How does that actually work under the hood, though? Because an image of a broken machine part and a text log describing a heat variance, those are fundamentally different types of data.
They are. The mechanism relies on something called vector embeddings.
Vector embeddings, okay.
Yeah. The multimodal AI takes a video feed of a manufacturing process and a text-based maintenance manual, and it mathematically projects both of those inputs into the same multidimensional space.
Wait, so it turns them both into math?
Exactly. It turns the visual of a rusted gear and the text description of corrosion into numbers. And those numbers live close to each other in its mathematical understanding.
Oh, wow.
This allows the agent to essentially see the rust and instantly cross-reference it with the text manual to formulate a solution.
Without a human needing to type out, the gear is rusty.
Exactly. It just knows.
The healthcare cluster in Tampere provides a really compelling look at this. The source material highlights hospitals deploying these multimodal agents for diagnostics.
Yeah, that's a brilliant example.
They have systems that take a patient's medical history, which is, a massive text file, and cross-reference it with live medical imaging like MRIs and clinical video of the patient's motor functions.
Right.
And the agent synthesizes all those different modalities simultaneously to highlight anomalies for the attending physician.
Just think about the research applications there. We are looking at agents capable of synthesizing decades of published medical papers,
Yeah.
pulling raw data from conference presentation videos, cross-referencing vast imaging data sets. They spot patterns across different media formats that human researchers simply don't have the bandwidth to process.
Because of the sheer volume of data.
Exactly.
But the case study that really illustrates the enterprise impact, for me at least, was a mid-sized machinery manufacturer in the Tampere region.
Oh, yes.
They didn't just give their AI access to text-based ERP software. They deployed what the research calls an agent mesh.
Right.
They had specialized visual agents watching high-speed video feeds on the assembly line for quality assurance.
While simultaneously, telemetry agents were pulling heat and vibration data to predict machine failure.
Yeah, and procurement agents were negotiating material deliveries
Well,
all at once.
And this machinery manufacturer validates the BCG data perfectly. By running this multimodal agent mesh, they saw a 28% jump in production efficiency in just 6 months.
6 months.
Yeah. And unplanned downtime dropped by 42%.
Okay, so they achieved this incredible 28% efficiency bump. But if they are letting autonomous agents run the factory floor, how are they not running afoul of European regulators?
That's the big question.
Because regulators are terrified of black box AI. And the most surprising stat from that Tampere manufacturer wasn't the efficiency gain. It was that they underwent a rigorous compliance audit and hit 0 findings.
Which is almost unheard of. Achieving 0 compliance findings with an autonomous system is incredibly difficult.
Yeah.
And this brings us to the core of the EU AI Act, which treats AI very differently from previous tech regulations. It doesn't view AI as a monolithic software category. It introduces a strict, risk-based classification system.
Let's break down those classifications, because this directly dictates what an enterprise is legally allowed to deploy.
Right. So the Act segments AI into 4 tiers. Minimal risk, limited risk, high risk, and prohibitive. The critical takeaway for anyone architecting enterprise systems is that multi-agent orchestration networks almost entirely fall into the high-risk category.
What specifically triggers that high-risk designation? Is it just the fact that they're autonomous?
It's the domains they influence.
Ah,
If your agent network is managing critical infrastructure or making decisions that affect employment or worker evaluation,
or determining the allocation of essential services.
exactly, then it is legally classified as high risk, and that designation requires mathematically rigorous bias testing on the training data sets to ensure the system isn't skewing decisions.
Right.
It requires mandated human-in-the-loop oversight mechanisms. And most challengingly, it requires exhaustive data governance.
Meaning the audit trails.
Yes.
Like, if Agent A tells Agent B to halt a production line, the regulator needs to know exactly why.
You need an immutable, cryptographically secure log of every decision and the exact data that influenced it. If a regulator knocks on your door, you cannot just say, well, the algorithm decided it. You have to produce the exact context window the agent was operating under at that specific millisecond.
Which explains why so many companies are failing at this right now. We see organizations buying off-the-shelf generic AI platforms.
Oh, makes sense.
They try to take a massive generalized model, plug it into a complex European factory, and then retrofit the compliance onto it.
Yeah.
They treat governance like a software patch they can just bolt on after the system is already making decisions.
And it's a fundamentally flawed engineering approach.
Right.
If the core model wasn't trained with those strict compliance boundaries, you can't just put a filter on top of it and expect it to survive an audit.
It's like trying to bake the flour into a cake after it has already come out of the oven.
Exactly.
You can put all the compliance frosting you want on the outside, but structurally, it's a mess. The compliance has to be mixed into the training data and the core logic from day one.
That is exactly the philosophy behind the AetherDEV approach highlighted in our sources. They utilize what is known as AI-led architecture.
Right.
Instead of buying a generic bot and wrapping it in rules, custom AI agents are engineered with compliance checkpoints deeply embedded into their decision-making pathways.
So it's native.
Yes. The audit logging mechanisms and governance frameworks are native to the agent's code.
So before the agent even executes a task, the governance layer has already validated that the action falls within the company's risk tolerance and the EU AI Act's parameters.
Exactly. And we can see the market validating this architectural philosophy. European venture capital funding for AI governance and safety startups increased by 220% year over year, heading into late 2025.
220%.
Yeah. Institutional investors realize that compliance is no longer just a legal burden. It is a foundational requirement for doing business. Organizations utilizing embedded compliance approaches like AetherDEV eliminate the massive technical debt of retrofitting, and that makes them significantly more attractive to partners in highly regulated supply chains.
I have to play devil's advocate here, though.
Okay, go for it.
I am looking at this from the perspective of a CTO. I need custom-built, highly compliant, multimodal agent mesh networks that can watch video feeds, negotiate supplier contracts, and cryptographically log every internal thought process for an EU auditor.
Right.
Building that across multiple facilities sounds like an absolute operational expense nightmare. How does this not bankrupt an IT department?
It seems highly counterintuitive, I know. But when you architect an agent mesh with strict operational discipline, it actually reduces AI operational expenses by 35 to 50%.
Wait, really?
Really, poorly designed agents are massive compute-draining cost centers. Well-architected systems optimize compute so aggressively that they become profit centers.
You build a vastly more complex network of agents, and your cloud computing bill drops by half.
Right.
Walk me through the actual mechanics of that, because that math sounds impossible.
It comes down to 3 specific technical strategies the source material outlines,
Hmm.
starting with model quantization.
Okay, quantization.
When an AI model is initially trained, its internal mathematical weights are usually stored in a format called 32-bit floating point precision.
Right.
This means every single number the AI uses has a long string of decimal places, which requires massive amounts of RAM and processing power to compute.
So quantization is basically rounding those numbers.
Essentially, yes. Quantization compresses the model by converting those 32-bit floating point numbers into 8-bit integers. You are trimming the extreme decimal precision.
Ah, okay.
This shrinks the physical size of the model by 60 to 80%. And because the model is smaller, the inference cost, the actual computing power required to generate an answer, plummets.
Wait, does dropping that mathematical precision make the AI hallucinate more or become less accurate?
If done poorly, yes. But modern quantization techniques isolate the most critical neural pathways and preserve their precision while compressing the rest.
Ah, that's clever.
The accuracy drop is often less than 1%, but the cost savings are exponential. You're no longer paying a supercomputer to do basic arithmetic.
Okay, that covers the size of the models. The second mechanic mentioned is shared compute and intelligent task routing.
Right. In a naive deployment, a company might route every single employee query or system task to a massive, expensive, multimodal model.
Which is overkill.
Incredibly wasteful. Intelligent task routing utilizes a mesh network where different agents have different sizes and capabilities.
Oh, I see.
If the system needs to categorize a text-based email, a router sends that to a tiny, highly quantized, practically free model. You only wake up the massive, expensive executive model when you have a complex problem requiring visual and data synthesis.
You pool the computational resources and distribute them based strictly on task complexity. That makes a lot of sense. You don't ask the chief financial officer to calculate the tip on a lunch receipt.
Perfect analogy.
Now, there is one more highly technical piece here that solves the biggest cost issue of all. Getting the AI to actually know your proprietary company data.
Yes, crucial.
The source talks about a RAG retrieval, augmented generation, and MCP model context protocols. How do these mechanisms actually work to save money?
Historically, if you wanted an AI to understand your specific manufacturing tolerances or your internal HR policies, you had to fine-tune or retrain the neural network on your data.
Right.
Retraining models takes vast amounts of GPU compute and is incredibly expensive. Furthermore, the second your company policy changes, the model is out of date.
So RAG bypasses the retraining process entirely.
Yes. Think of RAG as giving the AI an open book test. Instead of trying to force the AI to memorize your entire company database, you detach the reasoning engine from the knowledge base. When a user asks a question, the system first searches your secure company database, retrieves the exact relevant paragraphs, and injects that information directly into the AI's context window along with the question.
Wow.
The AI simply reads the retrieved data and generates an answer. You get highly accurate, company-specific outputs without ever spending a dime on retraining.
But in a multi-agent system where dozens of agents are pulling data from HR databases, financial records, and supply chain logs, how do you prevent an agent from accessing something it shouldn't?
Good point.
How do you maintain the security required by the EU AI Act?
That is where Model Context Protocols, or MCP, come in. MCP acts as the standardized secure handshake between the AI agent and your data sources.
A handshake, okay.
When Agent A tries to retrieve a file using RGA, the MCP verifies the agent's identity, checks its permission scopes, and securely formats the data transfer.
Nice.
Crucially, MCP logs the entire transaction. It creates that immutable audit trail the regulators want, proving exactly which agent accessed what data and when.
So MCP is the bouncer checking IDs and keeping the logbook at the door of your database.
Yes, exactly.
Taking all of this into account, the compliance hurdles, the multimodal capabilities, the cost-saving architectures, what does the actionable roadmap look like for a listener evaluating their strategy right now?
Well, the source material lays out a highly pragmatic timeline for hitting that 2026 deadline. In the immediate term, the next 3 to 6 months, organizations need to conduct a comprehensive capability audit.
Right.
You have to map your existing processes against the EU AI Act's risk tiers. You need to identify precisely where a multi-agent system would be classified as high risk and where your current data governance has blind spots.
And during this audit phase, companies should be piloting single-agent systems in minimal risk domains, right? Just to build internal engineering muscle memory without exposing themselves to regulatory blowback.
Correct. Then moving into the 6 to 18-month window, that is when you begin deploying multi-agent orchestration for high-value operations.
Got it.
But that deployment must be paired with rigorous automated testing frameworks. You need systems constantly stress testing the agents for performance degradation and bias. Inadequate testing is the primary driver of agent failure and compliance violation.
Looking at this entire landscape, from the factory floors in Tampere to the nuances of vector embeddings and compliance architectures, what is the single most important takeaway you want the listener to leave with?
I'd say it is the sheer scale of the capability leap. We are moving from rigid text-based workflows to multimodal agent orchestration that can perceive, reason, and act simultaneously.
Yeah.
When a manufacturer sees a massive drop in unplanned downtime because an agent can simultaneously analyze a video feed of a machine and cross-reference its telemetry data, you realize this isn't just an iterative software update.
Right, it's bigger than that.
It is a fundamental transformation of enterprise capability. It yields efficiency gains that were mathematically impossible with sequential processing.
My takeaway builds directly on the reality of implementing that capability. Generic AI is a dead end for the enterprise at scale.
I agree.
If you are operating in Europe, you cannot simply buy a subscription to a generalized AI platform, bolt some rules onto it, and expect to survive a 2026 compliance audit.
It just won't work.
Custom agent development utilizing an embedded governance approach like AetherDEV is the only sustainable path forward. You have to architect the compliance into the core of the system. That is how you turn the heavy burden of European regulation into a competitive advantage that your rivals cannot easily replicate.
Absolutely. And as you look at your own enterprise roadmap, there's a broader conceptual shift to consider here.
Oh,
If you successfully engineer this, if your multi-agent mesh becomes perfectly compliant with the EU AI Act, highly cost-efficient through quantization, and capable of autonomous negotiation and problem-solving across your global supply chain.
right.
At what point does your AI system stop being categorized as just an IT tool and start functioning as your company's most valuable, albeit synthetic, employee?
Wow. That is exactly the kind of question we are going to have to answer a lot sooner than anyone anticipated. For more AI insights, visit etherlink.ai.